Community, we're back. Thank you for waiting. Sorry, I hope that wasn't too long. We're still at the PX4 Developer Summit. Remember, PX4 Autopilot is the #1 open source autopilot. Let us know how this is going. Please share your comments on the chat. Let us know in Slack. We're here waiting for your feedback. I have with me on the line Avaz Maski, who's calling from Japan. He's a PhD student at Kyushu Institute of Technology and has been directly involved in 4 different satellite CubeSat projects, placing 7 satellites in orbit. All right, let me change to my live video here. 7 satellites in orbit. This also involved building and launching the first satellite of Nepal, Nepalisat #1. He's interested in camera design for space applications, machine learning for image classification, and is actively working towards educating the next generation of Nepal through hands-on educational satellites called CanSats since Nepal first training in 2016. Wow, that's a mouthful. I'm really excited. Avas, can you still hear me? All right, so let me just switch to you right now.
All right. Thank you so much. Thank
You're
you for
welcome.
that.
Take it away.
Yeah, thank you for that introduction. Looks like I don't have to say much about myself now. Um, okay, let me just share that screen. Can you see my screen now? All right. Okay. Hi everyone. I am Abbas Maske. I'm currently a PhD student, but I'm also managing a Birds 3 satellite project that built the first satellite for Nepal. And today, I'll be also talking about CubeSats, but primarily focused on CanSats. And I'll be discussing about how I've used PX4 for educational satellites called CanSats, and what the state of present and post-pandemic prospects for CubeSat CanSats can be for using drone technology. Okay? So these are the agenda for today. So I'll do a bit of introduction, and then we'll move on to drone CubeSat connection, because I think I'll have to introduce what a CubeSat is. And then from CubeSat, you will understand what a CanSat is. And then I'll display what has been done in Nepal for CanSat, and then how PX4 has been implemented on it. All right. So my schooling was done in Nepal, Korea, and right now in Japan, involved in 4 different projects, including Birds 3, which is the one that I'm currently leading. And we also built the first satellite for Nepal called Nepalisat 1, alongside Ravana 1, which is also the first satellite for Sri Lanka. And the way I got into CanSats, the main reason why I'm doing this presentation is because of the leadership training that I received in Hokkaido University. And since then, I've managed to do 4 different, actually 5, 6 different CanSat programs in Nepal. Okay, so let me move on to CubeSats. So what are CubeSats? So it's basically a satellite standard for nanosatellites. Nanosatellites are 1 to 10 kilo class. The size is anywhere, you can make it bigger, but the standard size, 1U size, is 10 by 10 by 10 centimeter, weighs about a kilo, and are single watt systems, right? So what you can do basically is stack them. So you can take a 1U and then make it 2U and make it 3U if you need more power or volume or size, okay? So these are not big systems. You can fit them in your hand, as you can see with the Rebux Cube. If you look at the trend of CubeSat, it's growing exponentially every year, which is good news for us because we have more players. That means more innovation. Kyushu Institute of Technology ranks #1 in the world for small satellite launches from universities. Okay, so we have so far launched 16, and this year we're planning to launch 3 more. That's part of the Birds 4 satellite project. So we have excellent center for nanosatellite testing here at QTech, and as you can see, you can see we have space environment and also we have rocket environment testing. So these are all the satellites we have tested in QTech, including Birds 3. This is basically a typical timeline for what a project, a CubeSat project looks like. You can see that from kickoff to deployment, it takes around 1.5 years, and then we go into operation mode for 2 years. These are some of the images we have received from space. We have received images of Nepal, Sri Lanka, and Japan. These are the stakeholding countries. And we have collaborated with other countries to downlink their images as well using our satellites. It's also recognized worldwide. We have won the 2017 Diversity Award and also Better Satellite Award in 2019. So let's move on to drone and CubeSat connection. So what I feel and what I see at least, and this is just my opinion, is that drones are fast followers of mobile technology. So whatever technology is being developed for mobile phones, it's slowly trickling down to consumer drones. And from there on, what I see is that CubeSats are basically following the trend that drones are making. So all of the technology that are being implemented on drones are slowly being trickled down to CubeSats. So basically, there is just two main aspects of it, right? So if you really talk about it, it's software and hardware. Let's look at operating systems for satellites. So what I've seen through my personal study is that the use of operating system is increasing year by year. Um, so what I see is that in the future, we'll have more implementation of operating system. Um, the most of those operating systems are free and open source. You can see that educational organizations and private companies are utilizing free and open source softwares. But the issue has been they are not reliable enough. Reliability is still an issue. For the highest mission success, you can see that the um, the satellites with no operating systems are performing the best. And CubeSats are also dependent on the market. So we are using commercial off-the-shelf components, using processors and sensors that are available in the market. What we also see is that there is an increasing trend in using STM32, even in Japan, which primarily uses PIC for space systems. They're slowly changing into STM32s as well. This is very common that I saw in drone systems as well. So since there is a strong supply and strong demand for STM32s, I think this is going to be the standard in the future as well. So this is basically coming up from the drone industry, um, as you can see. So if you think about it, there is a lot of design similarities. You have constraints in power, weight, volume, cost. Attitude control is a little different because drone is airborne and satellites are spaceborne. But then you're using COTS, you're using the sensors, you're trying to do wireless communication, and reliability is always a factor in it. So I think everybody can sort of resonate with this. We go through the triple T standard, test, test, test. I think with drones, you do that as well. Um, at least through a perspective of somebody who develops CubeSats, I see that drones have mature open source operating system, have mature software in loop simulations, are network connected, and use AI. So they are already doing edge AI. So there is already a talk of software-defined drones, which is very interesting. So if we were to follow the path, um, let's say we were to implement what drones used, then we can repurpose the operating system that drones have used, right? we can repurpose the software in loop simulations. And since we have access to drone hardware supply, I think the future can be protected that way. So we could, if we're following the path that was set by um, by drones, then we can probably talk about software-defined satellites in the future. So let's talk about CanSat development in Nepal. So what are CanSats? CanSats are non-flight satellites primarily designed for educational purposes. And it's a tool to prepare students and faculty for future CubeSat projects. As you can see here, a can, uh, you can fit a can as a satellite inside a can, and you can see that as it has evolved, uh, there are components used from drones. There are also rovers that are sort of pseudo CanSat, pseudo rovers, and these are specially used for bring back missions in a competition called Alice. You'll notice here, Jay is here from PX4. So the way I got into CubeSats is also through CanSats. So CanSats are very important for anybody who's starting out with CubeSats. So I began with Korea CanSat competition in August 2014, then got to participate in CanSat leadership training program, which trains people to go back to their country and then start CanSat programs, right? So Nepal didn't have any CanSat program before. So I launched a pilot program in Kathmandu University in December of 2016. And then since then, we have done it every year. The one that I'll be focusing today is the one that we did in September of 2017 in Institute of Engineering. Um, One thing to note is that all these programs are free. And also, as we move on to 2018, 2019, and 2020, we are trying to target a younger audience while using the next generation of trainees. So there is a new generation of trainees and a new generation of trainers, right? So that's the model that we are moving forward in. So let's look at PX4 being implemented on the CanSat. As you'll notice that these are just drone components. You have GPS, you have, so what I did was I just used the Wi-Fi for communication. And then you have the onboard computer, which is the Pix Racer. This size was perfect for me. And then for EPS, I didn't use this board, but I used another board. But basically, the idea is to distribute the power and charge the LiPo. And then you have the battery, which is a standard LiPo that you can buy off the shelf. And the structure was designed in SolidWorks. Um, the structure is then printed out using 3D printing. In mechanical engineering, we call it additive manufacturing. That's just a nice way of saying it. And then you have, as you can see from before, it's just been neatly packed into a small, let's say it does look like a pico satellite. So 50 by 50 centimeter and then 75 centimeter. And then you have a parachute here that goes and attaches here so that it doesn't fall straight to the ground. And this is just an example of the testing. Once the hardware is integrated, all I had to do was load the PX4 firmware and then link it up with Wi-Fi. And now I had a CanSat that was working. So I was using all the sensors and let's say the GPS and everything from drone and then utilizing on a CanSat. And what I did was I tested the distance because distance does matter in our case. And 100-meter transmission test between the Wi-Fi of the laptop and the CanSat was possible. And for on the laptop itself, for ground station, I use Q ground control. So just a standard way of using drones as well. So this is these are some of the images that were taken during the 2017 CanSat training. You will notice that students are using the PX Racer, and they're placing it on the structure, then loading up the firmware and then testing it. Yeah, so the next slide will show how we deployed it. We didn't have any deployment mechanism at the time. So what we did was we basically climbed to the top of the building, to the roof, and basically threw the CanSat. And probably around 10 meters of height. So the 100-meter was that we tested was more than enough. After, let's say, deploying, we then did data analysis. The students looked at the data and then tried to analyze how the CanSat was moving, how much distance it covered, and so forth. So if you look at the future, there are a couple of challenges. First thing is, it cost me $100 to make one of those CanSats. And that's still high because an engineer's income in Nepal is $300. I think this is really funny, probably in Switzerland, but that's the reality back home. So that's significant amount, right? $100. And another issue I saw was that components, let's say I want to buy PX Racer in Nepal, it's not possible. So component availability is also an issue. So what I challenged the next generation of trainers to do was to build up CanSats with components that are available in Nepal, right? So use what is available in Nepal. So that was what we did since 2018. That's why we had to discontinue using PX4. But then, because of the pandemic, starting to look back and see if I can leverage drone technology in CanSats and CubeSats. Let's have a look at the future then. So one of the things that Jay from PX4 and I've been working on, basically he's been doing the work, is on the software in the loop simulation. So that's a game changer, I think. All you need is a laptop, and you can program and then run that program on to the simulation. In this case, it's Gazebo using PX4, and that allows us to adapt to social distancing as well. And there is potential for future virtual CanSat trainings and competitions, and these are going to be very low cost because laptops, most people already have laptops. You don't need to invest in a separate CanSat. And I think there's huge potential in this area. With that, I would like to just conclude my presentation. Thank you.